So what we're going to do is to take the exact same strategy we used when we had a small number of choices, right, only 3 options for each firm, and use it to figure out the best response, the optimal choices, when each firm could produce as much or as little output as they want. So how are we going to do that? We're going to do that by employing the exact same logic of Nash equilibrium that we used in our discrete game. In other words, we're going to say, we're going to find a Nash equilibrium when the output produced by General Motors is their best choice given the output produced by Ford, and the output produced by Ford is their best choice given the output produced by General Motors. In exactly the same way that we said that 15,000 and 15,000 is a Nash equilibrium, because when General Motors produces 15,000, Ford will want to produce 15,000. When Ford produces 15,000, General Motors will want to produce 15,000. We're going to use that exact same logic. So to do this, let's think about the price of output as a function of each of the 2 firms' choices. So we know that the price is going to equal 100,000 minus 2 times Q. But we know that big Q is just the output produced by Ford plus the output produced by General Motors. So I'll say P of QF and QGM is going to equal 100,000 minus 2 times QF plus QGM. So if I want to know Ford's best decision, best choice of output, what I'm going to do is I'm going to try to figure out what Ford's best output decision will be, taking the amount of output produced by General Motors as a given. In other words, we'll say, after we find out how much General Motors produced, let's think about how much output Ford would have liked to produce. Because we'll be at a competitive equilibrium when the amount of output that Ford would have liked to produce when General Motors produces their output is the amount of output they'll actually produce. Okay, so to do this, let's think about Ford's marginal revenue as a function of price. The marginal revenue for Ford, right, and why are we doing this? Because we're saying that when Ford produces their profit maximizing amount, taking the output of General Motors as a given, they're going to produce where marginal revenue equals marginal cost. So Ford's marginal revenue as a function of their output and as a function of GM's output is just going to be P of Q, right, minus dP dQF, right, times QF. Why is this? Because their marginal revenue is going to be the price they can sell their output at, right, which depends on both companies' decisions, right, Ford and GM's decision. Sorry, it's the plus. Minus the discount they have to give for each unit of output by increasing the amount of output they're producing times the number of units they have to give a discount on. In other words, they're going to say the price of the unit that they sell, right, minus the change in price from selling an extra unit on all of their units. Not on all of the total output, because they don't care about lowering the price that GM can sell their stuff at. Okay, I hope this makes sense. So what's this going to be? This is going to be P of Q, which is 100,000 minus 2 times QF plus QGM. Plus dP dQF. What's dP dQF? Well, the derivative of price with respect to QF is just going to be minus 2, right? So this is going to be minus 2 times QF. right? In other words, their marginal revenue is going to be 100,000 minus 2 GM, 2 times QGM, minus 4 times QF. Now the reason I'm arranging it this way, right, with the QGM in here, is because the QGM is just some number that they have no control over, right? So 100,000 minus 2 QGM is essentially giving us the price if they didn't produce any output at all, right, or the marginal revenue if they didn't produce any output at all. This 4QF is something that they actually have control over, right? So this is going to be what we get from marginal revenue of Ford at QF, taken as given QGM. Great. So what are they going to do? They're going to produce where marginal revenue equals marginal cost. Right? So they're going to produce where 100,000 minus 2 QGM minus 4 QF equals 20,000. Right? And we just have to solve for QF. So we'll say for QF, is going to equal 80,000 minus 2 QGM, which is going to tell us that QF, as a function of QGM, is going to equal all of this divided by 4, right? So it's going to equal 20,000 minus 1/2 times QGM. You see? So what's this telling us? What's this equation telling us? It's telling us that if General Motors didn't produce any output at all, right? If they were completely out of the market, Ford would make 20,000 trucks. And that makes perfect sense, right? Because 20,000 trucks is the amount that we said a monopolist would make. But it's also telling us that the number of trucks Ford wants to make is going to decrease as General Motors makes more trucks, right? In particular, they're going to reduce their output by 1 every time GM increases their output by 2. And the reason for this is essentially that the more trucks General Motors makes, the lower the price is at which they're able to sell their trucks, right? So the fewer trucks they're going to want to make. Awesome. So this has gotten us to knowing if Ford knew how many trucks General Motors was going to make, this is going to be the number of trucks Ford's going to make. So the next thing we have to do is just go through the exact same process to figure out the number of trucks General Motors would make as a response to the number of trucks Ford's going to make. Right? This is Ford's best response function. So it's doing exactly the same thing in this continuous problem that's saying what Ford's best choice if GM made 10,000, and their best choice if GM made 15,000, and their best choice if GM made 20,000 is doing in the discrete case. So now we know Ford's best response, right? We know their best response is something like this, this, and this. So now in order to find our Nash equilibrium, we just need to find General Motors' best response. And we're going to do this in exactly the same way. We're going to say, if General Motors knew how much output Ford was going to produce, what would their optimal profit maximizing decision be, knowing the output that Ford produced? So we'll do the exact same process, right? We'll say that the price is going to equal, right, with QGM and QF. It's going to be 100,000 minus 2 times the sum of their outputs. right? So the marginal revenue from GM, marginal revenue of General Motors is a function of General Motors output and of Ford's output. Is going to be 100,000 minus 2QF minus 2QM, right? So this is all just, right, this is all the price, and then minus the PDQ times the quantity of GM, right? So minus 2 times QGM. Right, so now that we're thinking from GM's perspective, we're thinking about GM's marginal revenue. This last piece here, right, which is dP dQGM times QGM, is going to reflect how much an increase in GM's output is going to affect the value of GM's existing output. Right, just like Ford didn't care about lowering the price on Ford's units of output, GM doesn't care about lowering the price. Just like Ford didn't care about lowering the price on GM's output, GM doesn't care about lowering the price on Ford's output. Great. So now we're going to have, right, that our marginal revenue equal 100,000 minus 2QF minus 4 times QGM. We'll set our marginal revenue equal to our marginal cost. So we're going to say that 100,000 minus 2QF minus 4 times QGM is going to equal 20,000, right, which is GM's marginal cost. And then we're just going to solve for QGM, right? Again, we're treating QF as just a piece of the environment, right? A piece of the furniture, because GM can't have any effect on the quantity that Ford produced. They're taking it as a given. We're trying to figure out their optimal quantity given the quantity of Ford. So we'll say, right, 80,000 minus 2QF equals 4 QGM. So we'll say that QGM as a function of QF is going to equal this whole thing divided by 4, right? So that's 20,000 minus 1/2 times QF. Just the mirror image of what we got for Ford because of the fact that these two firms are facing the same problem. So again, right, what is this function telling us? This is telling us GM's best response. In other words, it's telling us the same thing we would know if we went through our discrete game and we said, well, what's the best move if Ford produced 10,000? It would be 15,000, right? What's the best move if they produced 15,000? It would be 10,000 or 15,000. What if they produced 20,000? It would be 10,000, right? We're doing this exact same process again. Only this time, right, instead of considering just these three options, right, 10,000, 15,000, 20,000, we're going to find their optimal level of output for any amount of output that Ford could produce. Wonderful. Okay, so at this point, we found Ford's best response function, which tells us the amount of output Ford would make in response to any amount of output General Motors would make, which we said is equivalent, right, of going through here and saying, well, if GM made 10,000, Ford would make 15,000, right? If GM made 15,000, Ford would make 10,000. And if GM made 20,000, Ford would make 10,000. And we found GM's best response to Ford, right? The amount of output GM would make for any amount of output that Ford might make. So what we want to do next is we want to find a Nash equilibrium. In other words, we want to find some combination of GM and Ford's output where neither firm would have an incentive to deviate, right? Where we'd have a stable conclusion to this game. So how are we going to do that? Well, how we did it in a discrete case is we said that a Nash equilibrium is some circumstance where Ford's best response to GM's move is the move that GM is responding to, right? In other words, when Ford plays 10,000, GM's best response is 15,000. And when GM plays 15,000, Ford's best response is 10,000. So how do we apply this logic here? Well, we would say that GM's decision, when Ford is responding to GM's decision, has to be GM's decision. In other words, I'm sorry, I know there's not an easy way to say this, or not one that I've found. GM's output when responding to Ford has to be the output that Ford was responding to. Right? Just like if we said, if GM's output was 15,000, right? So let's say this was 15,000, right? Ford's response to 15,000 would be 10,000. And GM's response to 10,000 would be 15,000. This is what we're trying to find algebraically. So how do we do this? We just plug in the expression for QF of QGM into GM's best response function. So we'll say QGM is going to equal 20,000 minus 1/2 times 20,000 minus 1/2 times QGM. Right? Which is Ford's best response function. And now we just solve for GM, for QGM. So we'll say QGM is going to equal 20,000 minus 10,000 plus 1/4 times QGM. Right? So solving for QGM, we'll get 3/4 times QGM equals 10,000. So we'll get QGM is going to equal 4/3 of 10,000, which is going to be 13,333. Okay. So let's see if this makes sense. Let's see if this is right. So if General Motors made 13,333 trucks, then Ford would make QF of 13,333, right? Which would be 20,000 minus 1/2 times 13,333. What's 20,000 minus 1/2 of 13,333? That's going to be 20,000 minus 6,666, which is going to be 13,333. So Ford will respond to GM making 13,000 trucks by making 13,000 trucks. What would GM do? If Ford made 13,000 trucks, QGM of 13,333 is going to be 20,000 minus 1/2 times 13,333, which is of course equal to 13,333. In other words, when Ford makes 13,330 trucks, GM's going to make 13,333 trucks. When GM makes 13,333 trucks, Ford's also going to make 13,333 trucks. In other words, this is our Nash equilibrium, right? When both companies know the other company is going to do this, neither company has any reason to make any more or any fewer trucks. Okay, so what's the punchline of all this? What do we learn about the outcome of Cournot oligopoly? Well, what we're seeing is that the amount of output being produced, as we expected it to be, ends up somewhere in between what would be produced if firms were perfectly competitive and what would be produced if there was a single monopolistic firm or if these two firms cooperated, right, colluded to maximize their total profits. Now, there's a couple of other things that I want to point out about a Cournot oligopoly, and hopefully we'll have a chance to look at this a little bit in our class exercises. The first thing I want you to think about is, how would this story have changed if instead of having two firms, I had a third? In other words, what if Toyota enters the picture now with exactly the same marginal costs as GM and Ford? Nothing would change in terms of the productive capacity of the economy, right? Any one of these companies can produce as much as they want at $20,000 a truck, but the total amount of output would increase. How can we see this? Well, let's think about the price when we've got a total of $26,000 of output, right? So the price of Q is 100,000 minus Q, right? So the price of 26,000 is going to be, or 26,666 is going to be 100,000 minus 53,333 is going to be $46,666, right? The important point here is, this is a lot higher than the cost of making a truck. So if GM and Ford were each making 13,000 or so trucks, Toyota would have every reason to step into the market and start producing, right? Because they would be making $20,000 on each truck. Now, would GM and Ford reduce their output enough to offset the increase in output from Toyota? No, because as we can see, right, they're each only going to reduce their output part of the way in response to increased total output, right? So if we add a third firm, we're going to end up with higher levels of output than if we only had two firms. And indeed, with Cournot oligopoly, the more firms you have, the closer you're going to get to a perfectly competitive marketplace. So if you're thinking about how to make an economy more efficient, and you think that Cournot oligopoly is a good description of that economy, breaking large firms into smaller pieces should be expected to lower prices closer to competitive levels, even if it does nothing to reduce the production costs of the firms themselves. Now, another thing I want to point out, and I know I'm hand-waving through this a little bit, but I assume you guys are mapped out a little bit after the last 40 minutes. Another thing I want to point out here is that we would have both Ford and General Motors producing output, even if they didn't have the same marginal costs. In other words, if instead of GM's marginal cost being $20,000, GM's marginal cost had been $25,000, they would still have an incentive to produce trucks. They would still make some of the trucks. And again, this is going to be for the same reason, right? The price we're ending up with here is well above both firms' marginal cost, right? If GM had a marginal cost of $25,000, they would still be making $20,000 on each truck if output was the same as it is now. If output was lower, which you'd expect if one of the firm's costs went up, their markup would be even larger. So in a Cournot oligopoly, we're not going to be producing in an input efficient manner because we'll have relatively unproductive firms contributing to output. Whether it's better to have more firms, including some unproductive firms, or to have a single very productive monopoly, is going to depend effectively on the importance of output efficiency versus the importance of input efficiency. Okay, wonderful. Thank you so much for bearing with me through this. In the next video, we're going to be talking about a different version of oligopoly, a different understanding of a very similar problem.